I'm just waiting if anybody else wants to join in. Okay, so I think everybody is back. So fine, what I was saying, I don't know what time it stopped. I didn't realize. What I was saying is that there is no physical reason except for that one can understand that this is kind of a scalar which is a measure of an interaction, and A alpha contains the interaction with the field, and dx alpha will be the, we will see the length element or a measure of position of your charged particle in presence of that interaction, right? Okay, so if I start with this action and I put back the components of A alpha here, I can write my...
Shouldn't it be 5 by C?
Sorry?
Shouldn't it be 5 by C?
That's okay. I put the C here.
No, inside A alpha, A subscript alpha, because
here to begin with, you must understand that there are no such reasons of having E, C, and dimensions here, right? And it doesn't make any sense whether C should be here or C should be here, or whether C should at all be anywhere, right? It's just that if I start with something like that and I put a C here and I do the mathematics, I get a expression where then I don't have to redefine my variables and I get it in the form I have already seen it, right? So you realize when I start with something like this, right? Here you remember we started with something like an alpha, right? We figured out that that alpha turns out to be MC, right? So here there is no reason why I put an E by C here, or whether you say that you put a C here, doesn't matter. You may not put an E by C here, you may not put a C here. It's just that you will have to later on then compare it with the expression that you have in your Newtonian physics and say, maybe you can start with a beta here. Just like you started with an alpha here, you start with a minus beta A alpha dx alpha. And you end up saying that beta comes out to be E by C when you compare it with your Newtonian expression. Okay, Rajat?
yeah, okay. Okay.
Right, so there is no reason. There is completely no reason why I put an E by C here and I don't put a C here. You can put a C here and put an E only here. It doesn't matter. Okay, so I'm just going to write everything by... Now what I'm going to do next is that I want to compare it with this expression. And get my Lagrangian. Right? So I'm going to write everything, both the integrals on the right hand side in terms of this dt. Right? So this dt is some time that is measured in a frame of reference with what you can think of as a rest frame or a laboratory frame. Right? So I can see the ds, it is related to dt. You can go back and check how it is related to dt. It was related to dt as c into 1 minus v square by c square times dt. So ds was c into 1 minus v square by c square into dt. ds by c is the proper time. So you have dt prime into gamma equal to dt. So that's where this comes from. Right. And, oh sorry, not an equal to. And put so this is a alpha d alpha is a, let me write it here. A alpha dx alpha is a scalar. So its components will be a0 dx0 and ai dxi. Right? So I'm just substituting that. Dxi is my vector dr and ai is my vector a. So this ai dxi gives me a dot dr and a0 dx0 gives me, so this c is gone now because dx0, rather let's write dx alpha is c dt dr. So these are three things that I put here, so I don't get a c here. Instead I get a phi dt a to b a to b. I'm still not having this in the form into dt, so I write it like this. Where what is v? This v is dr by dt. So I had a dr, I wrote it as dr by dt into dt. And then I took a dt common. So I have the expression for my s action as an L dt. So I can write my Lagrangian. You can see when interaction goes to 0, you get back your Lagrangian for a relativistic free particle. Minus mc square 1 minus v square by c square to the power half. So L free, that's first check. Second check, L Newtonian. What is the Newtonian limit? V being much, much smaller than C. It is this that's going to change. I Taylor expand this. I can write the first term as, after doing the Taylor's expansion. You remember? This is the constant term and I have half mv square plus E by C A dot V minus E phi. Except for this term, you've used this Lagrangian when we started with Lagrangian dynamics, when we were doing Lagrangian dynamics and we did charge particle dynamics. You have seen this expression. So Rajat, you see, I have got the correct expression C here and there doesn't matter. It's just that you have to match it with, in the end, your Newtonian expression. And then put all your constants in place. It really doesn't matter, right? So I have the correct Lagrangian. I'm happy with the Lagrangian that I have arrived at. Hence, I'm happy with the way I have defined the interaction in my system. So once I have the Lagrangian, I can do everything. So before I proceed, is there anything anybody wants to ask at this point? Okay, if you're happy, then the first thing that we can find is the momentum, vector momentum, three momentum, the vector component of your four momentum by doing del L by del V. You can solve this. We've solved this previously. This term for the free particle when we did it gives me, and now I have this additional term which is going to give me. So you can see that this is your P free plus E by C. So you must understand that to define conserved quantity, you see that the momentum here doesn't turn out to be just this part, but there's an additional term E by C A that we have. You can see that this, in the limit of interaction going to 0, becomes P free, and in the limit of Newtonian physics, when you will take the limit here, it just becomes right. So it's the correct expression for my momentum. I have the momentum. Now once I have the momentum, I can find my Hamiltonian from my Lagrangian. Hamiltonian by definition is this. So this is what I have seen, gives me P dot V. This is my P, 3 vector momentum, plus E by C A dot V. So this is what I've got from del L by del V dot V, right? And minus L. So minus L gives me minus E by C A dot V. This and this gets cancelled, and I get the expression for Hamiltonian Have I missed? Oh, there's a term here. I can combine these two terms. mv square, multiply this, there's a half here. Multiply this and take an LCM. Again, for a free particle where there is no interaction, it will reduce to mc square by 1 minus v square c square, which is gamma mc square. You've seen that expression for energy when we did in the beginning. We wrote down the Hamiltonian for a free particle, right? You've already seen this expression. So this again confirms what we've got, right? In fact, we should not, it's not a good practice to leave the Hamiltonian in terms of velocity, because when we do Hamiltonian dynamics, we treat position and momentum as our generalized coordinates, and we do not give the answer in terms of the velocities, but we write the Hamiltonian in terms of the position coordinates and the momentum coordinates. I leave it to you, it's not difficult. It's just substitute for V square in terms of momentum, and you'll be able to write this. So you will realize that instead of P square C square, you have P minus EA by C. We've already emphasized on this fact that when you go back and you look at the expression for the Lagrangian also, you have an expression where momentum is something like P minus EA by C. Right? The free momentum minus P free. So you have this sitting here. Remaining is M square C4 plus C square. You would have got P square. But you don't have P square, but you have P minus EA by C whole square plus E5. Right? So if interaction goes to 0, this goes back to M square C4 plus P square C square equal to E square. The expression that you have seen in your previous classes. Right? So I'm going to stop here. You can go through what we did right now, and if there's anything that you want to ask right now, you can ask. It's almost 10:30. In the meantime, I'll just click a picture of who all are there. There's one person who just came, in the sense was not there in the first half. I don't know who it was, but it's okay, doesn't matter. So I was thinking that let's not have a class tomorrow. You can study for your test. If you want to have some discussion session tomorrow, you can let me know. If somebody wants to have a discussion separately, if you have any problem to discuss regarding your test day after, so we'll not have a class tomorrow. You can take the whole day to study, right? And maybe ask me if you have any problems to discuss. You can share, you can write the problem over WhatsApp, and I will respond back to you. If all of you want to have a common discussion session tomorrow, you can tell me what time you want to have it, and we can fix it for tomorrow. Otherwise, I'm not going to do a class tomorrow. Day after, 10:30 to 12:30. We'll have the test between 10:30 to 12:30. And then we'll have a tute session on Thursday, right? So Thursday, we'll fix up a time during our lab time. I'll talk to Dr. Gupta if he's taking a lab theory on Thursday. And we can fix a tute class on Thursday, tutorial sheet for special theory of relativity, right? Or maybe have a theory class on Thursday and do a tutorial session on Friday. We'll see what we can do. But for tomorrow, I'll not take a class, but I'll be free to do a discussion session or problem solving session for you. It's not an issue. You can go through what we did today, and we still have few minutes, 1 or 2 minutes, and you can ask me whatever you want. Then I have a class with first year. Okay, then see you guys. If you want to fix up something for tomorrow, just let me know, right? Or else see you Wednesday, 10:30. You should, everybody should be there. I mean, those who can come over, Google, you should, those who cannot join the Zoom session or have any trouble joining the Zoom session, would like to use email or WhatsApp for taking the test, please let me know in advance, right? You should let me know by tomorrow evening what mode you're going to use for taking the test. I should be knowing, because we'll start the test at 10:30 on Wednesday, right? And I would not let anybody join later on. Somebody, whatever way you want to do, you have to tell me by tomorrow evening, right? And you have to be in place sharp 10:30, right? If you join after 10:30, I'm not going to consider that you took the test, please, right? And if there's anything, any other mode that anybody wants to use, let me know. Fine. You can write an email to me, or you can send me a WhatsApp message telling me how you would like to take the test. Okay, so then see you day after.